Hello and welcome once again to CaptainGoodspeed Maths. I'm Joe if you're new around here, and today we are discussing area between two curves. So we're going to talk about understanding integration to find the area between two curves. Last time out we talked about definite integrals, which is something very similar, but this time we're looking at the area trapped between two curves. So it's going to involve a bit of intersection and a bit of integration. So integration then, let's have a little look at what we've been doing the last two lessons. So basically we add 1 to the power and divide by the new power when we're integrating. Don't forget the c, but remember that c cancels out if we're doing definite integrals. Same applies here. So we've also learned to integrate between limits, which is what definite integrals are. So we've got the integral between a and b of f dash of x with respect to x is f of x between the limits b and a, which is essentially stick b through, stick a through, and take them off each other, where b is greater than a. So there you go. That's essentially what I've just said. Now then, let's think about two curves. So we're going to learn how to integrate or find the area between two curves. So the way to remember this is by integrating both curves algebra, then using the picture to help you. So we work out the area between the two curves by integrating, then subtracting the bottom from the top, or in simple terms, the integration between a and b of the ceiling take the floor with respect to x is equal to the ceiling take the floor integrated between the limits b and a, which is still equal to f of b minus f of a. So you'll get the idea as we look at examples. So there you go, integrate the subtraction of top and bottom and then put b and a through and subtract. So that's essentially what this means here, this little ceiling take floor. I'm trying to get my mouse. There we go. Ceiling take the floor thing here. So basically subtract them first and then do the integral and then put your limits through as you normally would. So example 1 then. Find the area enclosed by the curves y equals x squared plus 1 and y equals 9 minus x squared. So what we're doing here is find where the two curves meet, so we can find our limits. So remember, to find where curves meet, we set them equal to each other, so we know that y equals x squared plus 1 and y also equals 9 minus x squared. So that means x squared plus 1 must equal 9 minus x squared. So we stick them together like that. Tidy up, so you get 2x squared equals 8. Therefore x squared is 4. X is plus or minus 2. Stick it back in for y, and we get... Oh, actually, we just need the x's. We're not looking for full integration points. Remember where our goalposts went in the last episode was, or last lesson I should say, was the points in the x-axis. So we just need the x points of intersection, which are going to be 2 and minus 2. So let's draw a graph. So we've got y equals 9 minus x squared. As I said in the last lesson, you are going to have to know how to draw these graphs, otherwise you're just not going to be able to get started with these unless you can sort of interpret logically, picture these graphs in your head. Y equals 9 minus x squared is the sort of slopey one. I've actually labelled these wrong, believe it or not. I have labelled these wrong, so forget that. Swap them over. That is a massive typo. Here's me talking about, oh, you need to know how to do these graphs or whatever. But the upside down parabola is y equals 9 minus x squared, and you know that because it goes through 9 up here. And y equals x squared plus 1 is this one because it goes through 1 there. So basically we need to identify what is the ceiling and what is the floor. So let's have a little look. Oh, actually, yeah, we put up our goalposts as well at minus 2 and 2, so more information that we've got there. So essentially what we're looking for is this area between 9 and 1. So there you go. We've actually shaded that quite well. So let's keep going. So we need to know the ceiling take the floor. The ceiling in this case is going to be y equals 9 minus x squared, because that is this top curve here. So that is the ceiling, and the floor is x squared plus 1. So we're going to do 9 minus x squared minus x squared minus 1. There you go, I did it right at this point, so I knew what I was doing by then. So we perform this calculation and we get 8 minus 2x squared. So that is seal and take the floor, that is all you need to do. And now it's a simple definite integrals question. So we've got 8 minus 2x squared. We integrate that as normal, 8x minus 2x cubed over 3, add 1 to the power, divide by the new power. We stick the bigger limit through, subtract off when you put the lower limit through. Remember, 2 is bigger than minus 2. So we stick those both in, take them off each other, and just tidy up. And eventually you get 64 over 3 units cubed. So, or units squared, sorry, not cubed. But I was thinking, because 64 is 4 cubed. Yeah, so that's my excuse for that one. But there you go. That is how you do it. You draw your graphs. You put up your goalposts. You work out what's the ceiling, what's the floor. You take them away and integrate what's left. So we had our ceiling. We had our floor. We took them away from each other and integrated that. And then just did the maths. Easy peasy, definite integral. And we got 64 over 3 units squared. Example 2 then, find the area enclosed by the curves y equals 2x plus 3 and y equals x squared minus 4x minus 4. First, let's find where the two curves meet. So again, we know that y equals 2x plus 3 and we know y equals x squared minus 4 minus 4x minus 4. So therefore, 2x plus 3 must equal x squared minus 4x minus 4. So we set them equal to each other, tidy up, and we get that. Factorize, and we get x minus 7, x plus 1 equals 0. So our intersection points are at 7 and minus 1. So that is where our goalposts are going to be. So let's draw the graph, and we get this. So we've got the parabola, and we've got the linear line as well. But look at this. Stuff is going under the axis and everything. So we're going to have to do a lot of work in this one, I think. So put up our goalposts. So we've got one going at minus 1, and we've got one at 7 as well, because they are our limits, remember. So we shade the area, and we get that. We do the ceiling, take the floor. So what is the ceiling in this case? Well, the ceiling is this line here, and we've got the floor, which is the parabola. So we do line take away parabola, and we get that. And then we tidy it up and get minus x squared plus 6x plus 7. And then integrate that with respect to x. Put our 7 through, put our 1 through. Apologies that that's overlapped a bit. It's on a different version of PowerPoint to what I originally made it on. But you get the idea. You put the 7 through and you put the 1 through, take them off each other, and you get that. Tidying that up, you get that, which is 85 1/3 units squared. And there you have it. You now know how to work out the area between two curves. So if you found that helpful, make sure you leave a like down below. If not, then let me know what I can do to explain it a bit better. Remember that the lessons are all on the Google Drive and also in the playlist OCR FSMQ New Spec. I've also got the old Spec videos on the channel. If you thought I didn't explain it well enough in this video, maybe go and check out my other video on it in the old Spec, and you might get a bit more from it. Different day, different education, whatever. But yeah, subscribe to the channel for more FSMQ videos, and very best of luck with your exam.